Hello everyone, welcome back to the Android game tutorial. This is going to be the second episode, and today we will learn how to draw our little red square where the user touched the screen. Let's go! Before we start, this channel have a Discord server where you can discuss and ask questions about the tutorials of this channel. Or maybe you just want to swing by and say hello. We will also use GitHub throughout this tutorial. There you can check the most recent code, but also code from previous episodes. That comes in handy when something works differently on your side compared to what you see in the episode. And for the people that want to go the extra mile to support the channel, there is a Buy Me a Coffee page and also a membership option on YouTube with some basic perks. With that being said, let's get back to the episode. Let's take a look at our current code. We didn't do much in terms of coding last episode, but we did make this new class, and that class extended surface view, which will allow us to have something to display our canvas on. We also added a callback interface which will handle the surface changes not only when we first open the game, but also when we tab out of the game. And then in our surface created method, we retrieve the canvas, we draw on the canvas, and then finally we send the canvas to be rendered, and voila! Here is our little red square. Now let's see if we can draw the square wherever we are touching on the screen. To be able to handle any type of input from the user, we need some sort of method that is getting called whenever there is an event. And an event can be touch, it can be moving the finger, etc. Some sort of event. They're called events. And in Android we have a method called OnTouch. There's different ones, but we're going to use the OnTouch method, OnTouchEvent. And this OnTouchEvent is actually part of the view class which surface view extends. So surface view extends view, just like our game panel extends surface view. So we can then use this OnTouchEvent to handle the events. And in here we have a return to the superclass, and we are going to just comment that out, or actually we can remove it. And then we can say return true. And this return for us is pretty useless. We don't really need to care about it. But quickly, return true means that we have we tell the next layer, because it's different layers to handle events, but we're telling the next layer that we're returning to that we have handled the event in this section or this class or in this method. So it does not need to be handled anymore. If we return false, we haven't handled it. But since this is a game, every touch or event that we do, we are going to handle it ourselves. Nothing else needs to handle it. So return true, we have handled it. Return false, we have not handled it. So we're always going to return true because, well, we always will handle it in one way or another. And we're just going to make a quick check to see if this OnTouchEvent method works for us. So we are going to add a system.out.println, and we're going to say in here a string which will be user event, something like that. And this system.out.println is very useful for debugging, checking if something is being called, etc. And it's just a lazy way of checking if we enter the method or we enter the bracket, because this text is going to be printed out in the log. And down here we have different tabs, if you will, and we have something called logcat. Here we can filter out in the log, and since it's a system.out, we just put system.out here. And now if we run this, bring out our emulator, it's running this app right now and this emulator. And if I now press here somewhere, we get user event. And as we can see, every time we click on the screen on our game here, we get a printout of user event. We can see the timestamp, etc. So yeah, it's working. So that's great. Now we can move on to the next step. And the next step is to draw this little red square wherever we have an event going on. So if I click in the middle, I want the square to be drawn in the middle, and so on. And how are we going to do that? Well, when we draw the canvas, we actually need the surface holder to give us the canvas, and then we tell the surface holder to draw or render the canvas. But how do we get the surface holder when we are in our OnTouchEvent? Because we get our surface holder in our surface created automatically when the surface is being created or changes, etc. when there is a change in the surface. But we don't have it here, and we can't just add surface holder here. So how do we do it? Well, surface view can access the holder, which we do already here. We say get holder and then add the callback. So let's just add a private surface holder object up here. Holder, let's just call it holder. And we can then say holder is equal to get holder. It's the same method here. And we can change this as well and say holder.add callback this. And it's the same as this one. So we're using this holder object instead of saying get holder.add callback. It's the same, I just want to show that it's actually working. But now we have this holder object that we can use in our OnTouchEvent. So just like we do in here, we're gonna do the same in here. So we can remove this system.out and we can, let's copy this, and canvas equals holder.lockCanvas. And then we draw it on the rectangle, and then we say holder, unlock, and render the canvas. But right now it's going to be looking the same, nothing is going to change here. I click, nothing happens. And that's because the position of the square is still on the same place, 50, 50, 100, 100. So we need to get the position of the event. And we can do that by just saying the event that we get here, event dot get x, and they return float. So we say float x equals event.getx, float y equals event.getY. And now we can say x, y, and then of course x plus 50, because it's not width and height, it's the next position, so y plus 50 here as well. And now let's see if that works. It should work. Let's bring up our emulator. I'm gonna click in the middle. And it's kinda working, right? I mean, it's drawing a square wherever I press, and we get some flickering, looking weird. And what the hell is going on? I mean, it's working like 50% of what we want. We're drawing a rectangle, or the square, wherever we are pressing, but we have a lot of squares, and what's going on? Well, whenever we are drawing here, we're actually using the previous canvas and drawing on top of that, and then there is some flickering, not everything is getting drawn, it's just a mess. The way we're gonna solve that is by going in here, after we get the canvas, and we're going to say canvas.drawColor, color.black. So we're just drawing the entire surface black, and now if we run it again, and the canvas is being reset every time we get the canvas. So yeah, this looks much better everywhere I press. If I hold and drag, then it follows along. And so yeah, this is pretty cool. But let's take a look at our code for a second. Our code is not the cleanest. We have one canvas drawing here, we have another canvas drawing here. And what, should we have another canvas drawing here if we change or something happening? No. We should only have one method that handles all the drawing, and then we just call this method whenever we wanna, well, draw. So let's create a private void render. And this rendering method is going to use the holder object that we have here, surface holder. So we might as well just copy everything in our OnTouchEvent and paste it in our render, but we can't use the event in here, so we're just gonna remove that. We're gonna get errors, x, y, we don't have that yet. So let's go up here and create the private float x and y. And now we can remove the drawing from our OnTouchEvent. And instead of creating a float in here, we just remove float. So now whenever we are touching the screen, we're setting X to the event X position and Y to the, well, event Y position, and storing it up here. And now we can just draw our square wherever we last touched or had an event. And we can just clean that up a little bit. But in here we have the same looking drawing as before. We're just gonna remove that and say render. And of course we need the render in our OnTouch as well, because if we don't call render, since we have no game loop, we're not gonna update the position or the square. It's gonna be a new position, but we're never drawing the square on the new position, so we need to call render again. So let's see if this works. It starts at the top because X and Y is by default 0, so if I click in the middle, the event is handling the inputs and we're drawing the square wherever I am touching or dragging the mouse on the screen. Looking good. But we can make this far more interesting. Let's do that. Let's actually draw a red square wherever we are touching on the screen. Not just redraw one square, but add one new square every time we press somewhere on this screen. So how are we going to do that? Well, let's stop the app for now. And let's go ahead and just add a ArrayList. And an ArrayList is just, well, a list of something. And we can add to this list as we see fit, we can remove from this list, but we need some way of storing multiple positions. So every time I click on the screen, I add a new position and add this position to the ArrayList. And Android or Java comes with something called pointf for float. Otherwise we just point, but that would be integers, but we're getting actual float values from our event. So why not store them as floats? And what can we say? Square positions equals new ArrayList. And an ArrayList have been created of the type pointf or point floats. It says that pointf holds two float coordinates, x and y. Very simple, very good to use. Now, whenever we touch the screen, we want to store this position in the array. So how do we do that? We take this Control C and we say square position dot add new pointf. So we're adding a new point. And the point is going to be the event getX and then event.getY. Simple as that. So every time now there's an event on the screen, we're adding to this array list. So we can remove those two. And we can go up here. We can, let's comment them out for now. And we're gonna get an error right away because we don't have the X and Y anymore. We have a list or an array list of X and Y. And we want to loop through this array list. And we could of course use the most common loop in Java, which is a for loop. I think it's the most common one. It's the most common I've used anyways. But let's not. Let's actually use a enhanced for loop. So it's still a loop, but instead of getting the position every time I is 0, 1, 2, 3, 4, 5, we don't really care about the position. We just need to iterate through the entire array, and for every index or every position in this array, we want to draw a square at that position. So we don't really care if it's position 12 or position 512. We just, for every index in this array, we need to draw. So we can use an enhanced for loop for that. And first we need to specify what type of object, or if there's an array of class, whatever, that we need to use or we're going to use. And in this case it's a pointf, and we're gonna get a temporary object to this. For every iteration we get a temporary object that we can use to do whatever we want with it. And I'm just gonna say pos. And then those two dots, I don't know what they're called in English, but it's not semicolon, it's two dots. And then we need to give it the list or array list that we are storing all of this pointfs in, which is the square position array. And for every iteration, I'm gonna put it right there, we're going to say position.x, position.y, and that's how we're gonna get x and y. We're gonna draw a square at pos.x, and then of course pos.y. So it's the same. We get the x and y by just saying pos.x and pos.y. If we run it now, it should work, but the array list is going to be empty. at the start, so I don't think we're gonna have any squares in the beginning. Just gonna be blank or black. But if I click, 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 and I can also drag and add more. So each event, every time I move the mouse from one position to the other, we get a new square. So it's a very large array right now because we keep adding a lot to it. But yeah, but we do need to handle the type of event that's going to add a square to our array list. Right now we're adding a square for every type of event as long as we're just calling this method or this method gets called. And that is when we press down, when we move it around, dragging so to speak, or when we release the finger from the screen. But if we go in here and I click and I release, now there looks like it's just one, but it's actually two squares in this array. One for pressing down and one for releasing. So let's just add a square every time we press down, meaning that when we're touching it. And we can do that by just going in our OnTouchEvent and say if event.getAction, here we get the type of action. Is it a press down or a press or a release, or are we dragging, whatever. So we can make sure that we only add a square and render whenever we are touching it or pressing down. We can do that by saying event.getAction equals motion event, and we have a couple ones here. Button press, down, move, blah blah blah. We have a lot of different options here, but we want the action down. If the action is down, we're pressing down, add some brackets here. We're gonna add to the square array and then render. Otherwise, we don't do anything, we just return true. If we run it now and give it a try, I'm dragging, but there is nothing being added, only when I click, which is what we want. So we have a little bit more control of how many we add. Perfect. But we can make this a lot more interesting by randomizing the size and color of the rectangle. Let's do that. And to get the random value in Java, for whatever reason, we can use a class called random. And we're gonna call this rand for random is equal to new random. And this class is going to give us a random value of whatever range we are giving it. And we're going to start, before we use the random class, to make a simple inner class. And just like we can have a class like this entire game panel class, we can also have an inner class. This inner class is only going to be used by the class it sits inside, usually. And there's many reasons for using an inner class, but for our use case, we want to create a new instance of this class every time we have an event on the screen. And this instance of this class, inner class, is going to be put inside an array list. And every time we then want to draw, we loop through or iterate through this array and then draw whatever this class now represents. And this class only needs the position and the color and also the size of the square. So now let's go down here and just private class. And what can we call it? We can call it R&D random square. And then add two curly brackets like any other type of class. And we're gonna add a public constructor in here. Public R&D square. And what will we need inside here? Well, we need a point F for the position. We need a int color. An integer color. You can represent color in many different ways. I choose to use int for representing the color. It's very simple. We'll get to it in a second. But yeah, the color will be an integer. And then, of course, the int size. So we will have the same size in width as in height. We could, of course, add different for width and height. Alright, so we have the constructor set up. We will need a position, color, and size. Let's store them in here. So private point F position, and then private int size. And for color, we are actually going to create a color or a paint object in here. So private paint, paint. And in here we can say paint equals new paint, and then of course paint dot set color to color. So yeah, that looks good, but we of course need this dot position equals pos, and then this dot size equals size, and then we handle the color variable. All right, and in here we can add a public void draw, and all we need is the canvas C. And I think we can actually just copy this one and paste it in here and change it up just a little bit. Position.xy, but plus size instead of 50, because the size is going to be randomized, but not red paint. We're gonna use, well, paint. Alright, so this inner class is now complete. Let's go up here to our array list and change it up to a random square array list. And let's change the name of this array list as well to squares instead. I think that is a more fitting name. Now in our render, we are looping through something that holds point F, which is not what we want. We want to loop through something that is a random square. And we're gonna say square, and then of course squares. And we can remove this draw function and just say square dot draw, and we pass in the canvas. And for our OnTouchEvent, we're gonna keep the render, but instead of saying square position dot add blah blah blah, we're gonna remove that, and we're gonna get first a position, so point F is equal to let's call it pos equals new point F, and we have event.getX, event.getY. So the position is easy, it's wherever we press on the screen. So now we want a random color, so we need to store it in an integer. Int color is equal to color dot, and we have all of this preset black, red, white, yellow, and so on. But there is a method that's called RGB, and it's requesting 3 values, red, green, and blue. And if you used any type of painting software, you know that you can represent a lot of colors by just the value red, green, and blue. And it's up to 255, from 0 to 255. And that is where our random comes in. So for red, we're gonna say RND dot, was it not called random? RND? It was called rand. Rand dot next int, and inside here we're gonna set the bound. So from 0 to let's say 100, then we will get 0, 1, 2, 3, 4, 5, 6, blah blah blah, all the way up to 99. 100 is not the one we're going to get because it's within 0 and 100. So 0 to 99 if we pass in 100. So we're gonna ask for 255, which is the maximum in the color, but we just say 256. So we get 0 all the way up to 255. And then we just do the same for all the other colors. Rand, we can actually copy this, I think. Goes faster. That's red, green, and of course blue. So now we have gotten a random color based on 3 random values, 1 for each red, green, and blue. And then of course we need the size. Int size is equal to, here we can of course say random and then set the size. But what if we want the minimum of the width and height, the size of the square to be, let's say the minimum will be 25. And then we can add a random value, so rand.nextInt. And if we put 100 here, then we will get 25 plus 99 as the biggest and 25 plus 0 as the lowest. But I think that's a bit too big, or you know what, let's keep it. And of course, if we want the plus 100, we have to go 101. And that is the position, the color, and the size. All we have to do now is to say squares dot add new rnd square, position, color, and of course size. And we have just created a new random square. And then of course we render. So if we take a look at the code, it looks right. Let's give it a try and see if we get random size and also random color. That is dark green cyan something. That's pinkish. So yeah, we have random squares, and of course there is no limit to how much you can tweak and play with this, but I'm just showing that we can do some cool looking thing with random sizes and random colors with our user inputs. So yeah, this looks pretty cool. Alright everyone, that's all for this episode. With some user input and randomness, we can create something quite interesting on the screen. Don't forget to subscribe and like the video if you found this useful. The next episode will be about adding a game loop to our game. That is going to be an epic episode. Until then, take care now and have a wonderful day. Bye.